My name is Leah, and we're going to do number 1. 9,578 is equal to what in Mayan number system, which is base 20 instead of 10 like standard. And so we're going to do our place values here represented vertically in boxes. So for the Mayan system, we have our ones place, and then we go up by 20s. So we have our groups of 20s, groups of 400s, groups of 8,000s, and we're not going to do 8,000 times 20 because that's bigger than our number. We're trying to find the biggest group you can take out of this number. So we have one group of 8,000s from this number, but we have to know that the Mayan system uses different symbols than base 10. We've got the I symbol, which represents 0. Dots represent 1 each, and they have bars, which are 5 each. So right here we're going to put 1 dot, 1 group. So 9,578 minus 8,000 is going to be 1,578. How many groups of 400s do we have in this number? We're going to have 3. So 1,200. You're subtracting. And you're going to get from that number 378, but we need to make sure we put 3 groups of 400 in here. And now, how many groups of 20s are going to go into 378? We're going to have 18 groups. So 18 times 20 is 360, and we subtract that and get 18, but we need to make sure we put it in here, because we had 18 that we had multiplied. So 1 bar is 5, 10, 15, and then you have your 3 dots, which equals 18 groups of 20s. And we have 18 ones left, which we can definitely put in here. Because it's groups of 20s, you don't have to carry over when you reach 10, you carry over when you reach 20 groups of ones or 20 groups of 20s. So this is our answer right here. Question 2, we have 248562 base 11 plus 365082 base 11. We're representing these numbers with dots and boxes. And see, I labeled our numbers in the boxes and as dots. And our base is 11, not 10. So we are actually going up by 11 groups instead of 10 groups for our place values. We have 1s, we have 11s, we have 121, 1,331, 14,641, 161,051 groups. Also, because it's not base 10, we're going to have to make up a symbol, which is a star for this one, for number 10. So we have 10 groups of 1s, for instance. We're going to put a star down here, because it gets complicated with writing the number 10 down here in our place value. So 2 groups of 1s plus 2 groups of 1s is 4. We have, see if we have 11 groups here, because we have 6 plus 8, which is 14, so we definitely do. 6 plus 4 plus, okay, that's 11. We're going to transfer it over to the next place value because 11 11s, which is groups, times 11 is 121. And we have left over 3 dots, which is 3 groups of 11s. So now we have in our next place value 6. Over here we have 8, 9, 10, 11, 12, 13. So we have a group of 11 we can transfer over and do the same thing in the next place value. We have a leftover of 2 groups of this place value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 groups of this place value we get to transfer over as 1 dot in the next, 1 group in the next place value. So that's 0. And then we have our answer of 6. So 602634 base 11 is our answer. Number 3, 6,235 minus 3,876. We're going to use the lattice method. And so here we have our place values color-coded and labeled. And this method, we have our ones, place, tens, hundreds, and thousands that we're representing when we subtract. So let's insert our numbers. Minus 3,876. So here we go. 5 ones minus 6 ones. We can't do that. It's a negative, but we can actually borrow from the next place value up, so it's not going to be a negative. This is borrowing 110, and we're just moving up 5 ones. So 15 ones essentially minus 6 is going to be 9. 2 minus 7, no, we're not going to do that. So we're going to borrow 100, which is 10 tens, plus 2, we have 2 tens, so 12 tens minus 7 tens is going to be 5. And then we have to borrow again 11 minus 8, which is 11 hundreds minus 8 hundreds, really, is going to be 3 hundreds left, three groups of hundreds. And 5 minus 3 is 2. So we have our answer of 2,359. And here in the traditional method, we had to do the same thing, but it was trickier to actually carry over up here. As you can see, the place values are more tricky to see. And this is just a clearer method to keep track of what is hundreds and tens and ones and so forth. Number 4, we're going to use the lattice method using multiplying. So we have one product here and one product on the side represented by place values. We also have our chart that's going to separate our place values. It doesn't matter where you start, we're going to multiply the ones and then the ones with the tens, the ones with the hundreds, and so forth. All right, so let's do that. Okay, once you've done that, we're going to have our ones placed diagonally is 0, tens place, we're adding up, and we actually get 17, so we're going to have to do a plus 1 in the next place value because 10 tens is 1 100. So we're going to add up the hundreds now. 16 plus 1, just like we did before. 14 plus 1 in the next place value. 10 plus 1 in the next place value. 5 and 1. So you're going to get a total of 1,504,607. The standard algorithm, you have placeholders with zeros when you're multiplying, while with the lattice method, it doesn't matter. The order you multiply, they're clearly laid out. Number 5, we have scaffolding method, and we're going to divide these two numbers. So it's different than the traditional algorithm because it doesn't matter how many groups we get if it's the largest group or smallest group. So, for instance, 37 times 1 is 37. So let's subtract 37. But we have to put our one group and we're keeping track right there. So that will be 2,198. Now let's see, 37 times 2. What is that? That's 74. 37 times 3, 111. 37 times 4 is 148. 37 times 5 equals 185. If this is true, we know that when you add a 0 to it, it becomes 1,850. So let's try that number. We're going to do 50 groups of 37 and subtract that number. And we're going to get 348. Now let's try subtracting 5 groups. We're going to get 163 left. Now let's try 4 groups. Okay. We get 15 remaining. Now we're going to count our groups of 37, and here we have 60 groups, remainder 15. Okay, We got the same answer, so we are correct. Now, the nice thing is the difference between here in the traditional method, you have to do your place values right and in order with subtracting the largest group. But over here, it doesn't matter with the scaffolding method.